Layer 2, or the data link layer, provides physical addressing and access to media. It is concerned with how data is formatted from upper layers for transmission over a given network technology. It is also concerned with how access to the network is controlled. An example is Ethernet, which uses a MAC address, or Media Access Control Address. A MAC address is used as the identifier of a device. So on a network interface card, or NIC, a MAC address is burnt in by the manufacturer. MAC addresses are 48 bits in length, and they're broken up into two parts. We have what is called the Organization Unit Identifier, or OUI, and then a unique portion for this specific network card. MAC addresses should be unique, so the combination of vendor, or OUI, and a unique value should make the MAC address on a NIC unique. We'll spend some time later looking at this, but as an example, on my PC, I can use the command ipconfig/all to view the MAC address of my network interface card. So notice, on my Ethernet adapter, local area connection, I can see the physical address written in hexadecimal as follows. This portion identifies the vendor, or OUI, or Organizational Unit Identifier, and this is a unique value assigned to the network interface card by the manufacturer. MAC addresses use a flat addressing scheme. Unlike IP, MAC addresses only consist of a vendor code and a unique value. When installing network cards, you don't need to ensure that network cards of a specific manufacturer are in a single subnet or a specific subnet. MAC addresses are part of a flat address structure, unlike IP version 4 or IP version 6 addresses, which have a logical addressing scheme typically assigned by a network engineer, and addresses are grouped into subnets and configured appropriately. You would ensure in IP version 4 addresses, as an example, that devices configured in the same subnet are in a specific portion of your network. You wouldn't put devices in the same subnet and then spread them across your topology. However, with MAC addresses, you could have HP or Dell laptops spread throughout your network. You don't have to ensure that MAC addresses are sequential or that they are in a specific order. This layer also provides error detection, and in certain cases can correct errors that occur at the physical layer. When using Ethernet as an example, the data sent onto the network has to be formatted according to the rules of Ethernet. However, that data may traverse many links, and at another point in the network, it may traverse a WAN link that's using point-to-point protocol, or PPP. So the data link layer ensures that the data from higher layers is formatted correctly for transmission across individual physical links, where the physical link characteristics may vary. One link may be Ethernet, another link may use PPP across a serial cable, another link may be using DSL.